Hello everyone. In our today's problem, we have to count square submatrix with all ones, which is 1277 number problem in leetcode and a medium level problem. So you will be given an m into n matrix of ones and zeros. Return how many square submatrix have all ones. So all you have to return square submatrix that have all ones. Okay, so if we copy this problem statement and paste it here, if we have a look, this is one matrix will be given. You have to return the square submatrix that all have one. So our requirement is we have to return square submatrix, and this is number one. Second, second is the square submatrix have to have all one. Okay, so now if we just have a look, what does the square mean? Square means it have to have like both sides. It have to have same value, right? So here we can say 3 into 3. This is a square. 2 into 2 also a square, and 1 into 1 is also a square. So initially, if we have a look, how many square submatrix we have? So we don't need to count here. If we have a look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10, 1, 10. So one size of 10 we have, and on here all value is 1. That's okay. So we got 10, right? We got 10. Now we'll have a look how many square we have. Value with 2 into 2. Okay, so if we have a look, if I change the color, so this is one square. So we have 1, this is another square, 2, this is another square, 3, this is another square, 4. So we have 4 of 4 square, which is 2 into 2 into 2. Okay, and into 1 was 10. I hope you got it. Now we'll go for 3 into 3. So if we have a look, 3 into 3, there is 1, 2, 3, 1, 2, 3, 1, 2, 3, all have 1. So 3 into 3, we have only 1. So 3 into 3, we have 1. So 1. And then we'll go for 4 into 4, as our full matrix is 4 into 3 matrix. So now we'll go for 4 into 4. But as this matrix is 4 into 3, we won't be able to go for 4 into 4. So our final output will be 10, 4, and 1. Addition of 10, 4, and 1 will be 15. I hope you got it right. Okay. Now, if we have a look another one, this one, which is 101110, okay, and I'll just paste it here. This one is 3 into 3 matrix, right? So I'll write this one is 3 into 3 matrix. Okay, so first I'll check how many 1 into 1 we have. So there is 1, 1, 2, 3, 1 into 1. We have 6. Then I'll go for 2 into 2. Okay, so we have nothing here because there is 0. If we have a look, there is 0 also. Okay, we got 1, 2 into 2. So 2 into 2, 1, nothing else. Then we'll go for 3 into 3. So if we have a look in 3 into 3, we have 0 and 1 as well. So there is no 3 into 3 matrix which have all values of 1. So in total, we have 7. Okay, if we have a look, the answer should be the 7. Now, Now, how can we solve this problem? We can solve this problem using dynamic programming. How can you solve this problem? Using dynamic program. So in the dynamic program, all we have to do, mm, we can create another DP of n into n. Okay, n, then copy the whole value. All you have to do is like, if I take this one, I can explain it a bit more easily, and I'll put it here. Okay, so this is my original matrix. All I'll do, I'll create one more matrix, and I'll say if it is 0, leave it as a 0. Okay, if it is 1, so if the row or column is 0, I'll leave it as it is. So 1, column 1, 0. That's it. Now I'll go here. I'll check if the value of matrix is 1. Right. So there will be two value only, right? Zeros and ones. I'll say if the value of matrix, the current position is 1, what I'll check is there is all of my like nearest value is 1. Okay, so if I'll check here, here, and here. So the minimum value is 0. So this means like all of my nearest value is not 1. So what I will do, I will leave it like this. Or the simplest way to explain it, what I will do, I will add the current value plus minimum of my nearest value. So nearest value, which one will be the nearest value? Nearest three values, right? So which one will be I minus 1, j minus 1, I minus 1 j, and I j minus 1. So nearest three values. Okay, so I'll write nearest. Okay, nearest values. So our nearest minimum value is 0, and 1 plus 0 will be 1. Okay, then I will come here and I will check, is it 1? Yes, it is 1. So I will say if value can do this. Okay, so yeah, this is 1. Then I'll check what is our nearest value. Our nearest value, all of the nearest value are 1, means minimum is 1. So I'll do 1 plus the minimum value, which is 1, is equal to 2. I will explain why. Okay, I will explain now why we are doing this one. Because if a minimum, all nearest minimum values are 1, that's mean we got another matrix, right? Then we can say it's 2. Hope you got it. If there was 0, that's mean we are not able to create another matrix or submatrix where all of the values are 1. Have you got it? Now I'll go here and I'll check all of the nearest value. So 1, 1, 1 means minimum value is 1. What I'll do, 1 plus 1, which is, that's it. Then I will come here. I will check. I'll check the current value. Yeah, current value is 1. Then I'll go for the minimum values. Minimum value is 0. So 1 plus 0 will be 1. That's it. Now I'll come here and I'll check, is it 1? Yeah, it is 1. Then I'll go for minimum values. Here the minimum value is 1. Then 1 plus 1 will be 1. Okay. 1 plus 1 will be 2. So I'll say 2 here. Then I came here. I'll check. I'll say, is it 1? Yeah, it is 1. Then I'll check for the minimum values. So all of the values are 2. So what I'll do, 1 plus 2 will be 3. Means till here we can create three sub-arrays where all of three square sub-arrays where all of the value will be 1. Okay, so I hope you got it. Now all we have to do, we have to add all the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 12 plus 3 will be 15. That's it. For this one, if I say this one, for this one, all we have to do, we have to create a duplicate array, dp, and 1. So this value is 1. I look for all trace value. So the minimum value is 0. So 1 plus 0 will be 1. When this one is 0, I don't have to do anything. I'll come here. It is 1. I look for all minimum all side value, and the minimum value is 1. So 1 plus 1 will be 2. Then this is 0. I don't have to do anything, and then I'll add the all values. 1, 2, 3, 4, 5, 6, 7. So answer will be 7. I hope you got it. This is the simplest way, and that's how we can solve this problem. So if you have a look, here I said if you want you can create a DP, but if you want to save space complexity, you don't have to create DP. What you have to do, you can do addition while looping this matrix. So so you don't have to create any additional space. Okay. Okay. I can say 0. That's it. And at the meantime, I can do addition. Right. So I can say for int I equal to 0. So here I want to explain one more thing. What I'll do, I'll just create the subarray, create the matrix, updated matrix. I equal to matrix size. Okay. Here, here, that's it. And then what I'll say, if if matrix ij is greater than 0 or is equal to 1, is equal to 1, is equal to 0, greater than 0. Why I'm writing I and j is greater than 0? Because I don't wanna update the corner ones, right? So that's it. If it is, all we have to do, minimum value. So minimum value will be matrix of I minus 1, or uh, j, or that's how we can update the matrix. So we got our updated matrix. Now what we have to find how many metrics we can, how many square metrics we can create. So each and every time, all we have to do, we have to add the value of matrix to the response. So what I'll do, I'll just say response plus equal to matrix of I and j. This will be the updated value, and then at the end return the response. That's it. And if I run my code, so why it's not working? I'll have a look. the matrix of ij should be the plus. I have had a minimum value, right? So it would be the plus. Also, instead of equal 1, we can just say matrix of ij I will be the same thing. And if I run the code again, okay, I submit my code. Thank you so much.